So before we start the topic of this video, this is just a small reminder to remember all these values of fractions from 1 by 1 till 1 by 30. So these values help in conversion from fraction to percentage as well as conversion from fraction to decimal. How? You can just put decimal two places to the left side to get the decimal value because percentage means per 100. And now we will be covering the topic of ratio, proportion, and variation. So see, in the percentage, if we say that there is one quantity G1 and out of the total quantity, its percentage is G1 upon T into 100. And there is another quantity G2 in that particular set only and G2 by T into 100, right? So this gives a comparison of the given quantity to the total quantity. But what if you want to do a comparison between these two? So if you want to do a comparison, you just put a sign of division over here. And then by cancelling out the common values, you get G1 by G2. Now, this quantity can be represented in the form of ratios as G1 is to G2. And this is what ratio means. So, ratio is one of the best ways to compare two values. So, here we call it A is to B, wherein A is the antecedent and B is the consequent. So, the first value is antecedent and the second value is consequent. Okay. Then A and B have to be of same type and same unit. Yes, that is but natural. Same type means that they should be of the type either integers or decimals. Okay. So generally, the type of integers or natural numbers is what do we say? Ideated and it is preferred. Okay. And same unit means both the values have to be of same unit. For example, if G1 is in kilograms, then G2 also has to be in kilograms. And if G2 is in millions of grams, so we will have to do 1000 G2, G1 to make the ratio of same unit. Okay. Now there are some types in ratios, which means that if the first quantity is greater than the second, then we say that it is a ratio of greater inequality. If A is less than B, like the first quantity is less than the second one, it is a ratio of less inequality. And A equal to B, a ratio of equality. Okay. So that is pretty much it for ratios. And now we will look at the topic of proportion. So proportion means in how much quantity two things are present in a mixture. So for example, when two ratios are equal, two quantities are said to be proportional. For example, you have a mixture of two things, sugar and salt. So if we have 50 grams of sugar and 50 grams of salt, then we say that 50 is to 50, which can be reduced to 1 is to 1. So this is a ratio. And if we have another mixture, let us say of milk and water. Now, since these are liquids, so we will need to have them in liters. So let us say this is 50 ml and this is 50 ml. Then again, the ratio will be 1 is to 1 here. Okay. And when two ratios are equal, the two quantities are said to be proportional, which means that the ratios can be compared as 1 is to 1 is as 1 is to 1. So this is said as is to and this is said as is as. So it is a way of representing two equal ratios. Okay. So if A by B equal to C by D, then A is to B is as C is to D. And there are also various uh, representations of representing the same thing. For example, B is to A is as D is to C. Because if we reciprocate the both the terms, then we will get B by A is equal to D by C. And this will result in B is to A is as D is to C. Okay. Then A is to C is as B is to D. So you do the cross multiplication and you get this result. And A plus B is to B is as C plus D is to D. So what you can simply do is in these ratios, add 1 to both the sides. So A plus B by B is equal to C plus D by D, correct? And from it, we can write this thing. Okay. And the last thing, if A, B, and C are three numbers wherein we can write A is to B is as B is to C, which means A by B is equal to B by C. It is called continuous proportion and it means A, B, and C are in GP. And from GP, we know that the square of the middle term is equal to the multiplication of first and third terms. Okay. So that is pretty much it from the topic of proportions. And now comes the topic of variation. So what do you mean by variation? So variation is nothing but wherein one of the quantity is dependent on how the second quantity varies. Okay. So two quantities A and B may be such that as one quantity changes in value, the other quantity also changes in value, bearing certain relationship to the change in value of the first quantity. This phenomenon is known as variation. And what is the prime example of it? So the prime example of it is the speed, distance, and time equation, wherein we say that speed is equal to distance upon time. Or we can say that distance is equal to speed into time. So this is the prime example. Like if time is constant and V increases, D increases. If V is constant, time increases, D increases, and so on and so forth. Now there are certain nomenclatures of variations which are direct variation wherein A is proportional to B, which means A is proportional to B. This is the way we write the direct proportionality sign. And here we can say that A is equal to KB, wherein K is a constant. And yes, A1 by A2 equals to B1 by B2. So this is self-explanatory. Then there is another type of variation, which is inverse variation, wherein A varies inversely as B, which means A is proportional to 1 by B. Okay. And here we can write AB is equal to K, which is a constant. And A1 by A2 is B2 by B1. And the third type is joint variation, wherein one variable is dependent on more than one variables. Like distance is dependent on speed as well as time taken. Okay. So that is pretty much it from the conceptual side of this particular chapter. And now we will solve a question. So a container has 40 liters of milk. Then 4 liters are removed from the container and replaced with 4 liters of water. This process of replacing 4 liters of liquid in the container with an equal volume of water is continued repeatedly. The smallest number of times of doing this process, after which the volume of milk in the container becomes less than that of water is. Okay. So notice one thing, that concentration of milk is equal to milk divided by total into 100. And in every iteration, the total is 40 liters only. So we can write it as 2.5 m. Okay. And here the quantity of replacement is 4 liters. Like 4 liters of water is getting added. So there is a formula over here. Like if we write it as uh, final concentration. So final concentration is equal to initial concentration, which is 1. Okay. C is equal to 140 liters of milk into 1 minus x by t to the power n, where n is number of times replacement is done. Okay. So this is the formula for finding the final concentration based on the initial concentration. The quantity of replacement, like if milk is replaced with water, or like the solution is replaced with water, whose concentration will be counted as 0 since we are taking milk as a reference. So in this case only this formula is valid. Okay. So here the initial concentration is 1 and 1 minus 4 by 40, which is 1 by 10. So this is 9 by 10 effectively. So F is equal to 9 by 10 to the power n. And now this has to be less than 0.5. So here what we will need to do is we will have to take the logarithm on both the sides and then find the value. So log of 9 by 10 and n less than 0.5. And from this, you will be able to find the relationship. So this value is rather log 0.5. Okay. So you can do this calculation and you will find the value of n accordingly.